Alright, so you need to memorize all this stuff on this page. Now for the fun stuff. Now we're going to do the tangent lines. Oh boy, I bet you're saying. Find an equation for the tangent line. Find the equation of a tangent line to this graph at this point. So for a tangent line, I need two things. I need a point, cough, 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 and I need a slope. So guess what, guys? I already found my point. It's right here. Great. So now I need a slope. And here's how polars are similar to parametrics. The slope is dy dx. You need to know that. You need to master it in calculus, BC. Because it will haunt you. If you find things like dy d theta or dy dt, cough, cough, you will get these problems wrong every time. How do you find dy dx? It's going to be very similar to parametric. This is going to be dy d theta divided by dx d theta. I'm telling you, this is exactly the same as parametric, which for the record is 9-1. So if you want to see this played out a bunch of times in 9-1, be my guest. 9/11, I guess it looks like. I'm really tired. This lesson, gosh. All right. So you need to find dy d theta. We need to find dx d theta. That's going to be our two goals. That's going to be our two goals. So first, goal 1. Find dx d theta. First, notice x equals r cosine theta. R cosine theta, where'd you get that? A few pages back, we noticed that r was cosine theta. R cosine theta was x. X was r cosine theta. So, don't differentiate this. If you differentiate this with respect to theta, you have to worry about chain rule, you have to worry about product rule. Please don't. Instead, we're going to use this. Now, to make it simpler to plug in, let's replace this with r equals 2 minus 2 sine theta. Okay. Here I go. So if r equals all of that, I'm just plugging this in everywhere I see r, with parentheses, please. 2 minus 2 sine theta times cosine theta. 2 cosine theta distribution minus 2 sine theta cosine theta. Ugly, ugly, ugly. It's okay, though. It really is okay. Because now you're going to want to hate me. Save your rage for now. So if I differentiate x with respect to theta, this part's easy. What's the derivative of cosine theta? It's negative sine theta. Okay, make sure this makes sense to you. Over here, I have to use the product rule. Okay? First times the derivative of the second. Keep the first the same, negative 2 sine theta, times the derivative of cosine, which is negative sine theta. Oh boy, see, there's so much more room to hate me now. Plus the second times the derivative of negative 2 sine theta. Sine theta's derivative is cosine theta, so I have negative 2 cosine theta. Try it out. Make sure you get this when you do it by yourself at some point. That's why homework's so important. This can get really awful really quickly. I am going to simplify it. Am I? I am. Negative 2 sine theta plus 2 sine squared theta minus 2 cosine squared theta. Okay, if you're saying, oh, sine squared, cosine squared, it had to be plus. It had to be plus. Don't get happy. That's so disappointing. So hold back your tears. Choke back the sickness in your stomach. We're okay. That's finding dy dx d theta, part 2. Part 2, you may have guessed it already, children, was to find dy d theta. I believe this is more natural. Here we go. Y equals r sine theta. Sine. See? Happy, happy, happy. Why are we happy? Because then y equals, remember, r is 2 minus sine theta. 2 sine theta. Oh, man. 2 minus 2 sine theta. So that's what r is. Just to make it color-coded better. Was bothering me. Sine theta. Y equals 2 sine theta minus 2 sine squared theta. Okay. Get ready. Time to differentiate. This is no power rule. No product rule. No product rule. There's no products in here. Sine times sine. It's not the right way to do it. I hope you weren't thinking that. dy d theta. Okay, now 2, the derivative of sine is cosine. What's this derivative? I just want to say, remember, very important. I'm going to write it down here. You should highlight this. Write it in your notebook 100 times. Sine squared theta. I think in AB, this seems like a silly little thing we need once or twice. This is hugely important right now. Okay? So I'm going to have to take down the power. So d by d theta sine squared theta equals, bring down the power, 2 sine theta to the 1 power times the derivative of the inside, cosine theta. And that should make you really upset. Oh wow, it grabbed it? That's really annoying. Okay, what if I kill that? What does it grab now? Oh my gosh. It's being so dumb. Okay, I can live with that. So I can kill that. Sorry, I would re-record it, but it's been hours. dy. Okay, back to here really quick. Sine theta. It's the 1 power. I brought down the power, and then I multiplied by the derivative of the inside, cosine theta. Okay, I'm going to shrink that off. So that's what's happening. I will show you it in a second. Clean, 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 clean. Okay, here we go. So I'm bringing the power down. Oh, I should have used the same color, huh? I'm bringing the power down. I'm decreasing the power to 1. I'm going to give a sine to the 1 theta. Don't look at the sine prime, though. That's why I avoid writing it to the 1 power. Now you know the answer to that question. Times the derivative of the inside, which was cosine. I kind of have this memorized. It's rote for me. I just do it naturally. I'm not just trying to brag. I'm saying you might want to also just so you don't make calculation mistakes like forget the chain rule or forget to write sine. I've seen both happen and it's sad every time. Okay. Yay. No mistakes this time. This time? Yeah, there was another time. Okay, so now these both look awful. They really, really do. But it's okay, guys. We're almost done. So I have that shrunk. There we go. That's what I was looking for. I'm going to box this up. Okay. Sorry you weren't done copying it. You can rewind the video, though. I can't. I need to keep going on. Okay. Now the other part of our problem. Okay. Even if I write dy dx, finally, as the quotient here, you should notice something. Maybe pretty quickly. Maybe slowly. And that something is very sad for us. This is coming from here. This is coming from here. I'm not trying to sweep anything under the rug. This all has theta in it. So to evaluate at 2, 0, this point, I need theta for that point. Just like parametric. Look back at 9.1. It's always good to rewatch these. We need to define t to plug in. The t that would make this point. We need to find the parameter, the angle that will make this point. How? It's very similar to 9.1. If you can answer this quickly, it means you really understood 9.1. If you can't answer this quickly, you should watch 9.1 again, probably. 3, 2, 1. You can solve one of these two equations. Y equals, oh my gosh, y equals 0 or x equals 2. Go figure, right? Y was what? So this would be, I'll use that color again. 2 sine theta minus 2 sine squared theta. Oh man, sorry. Equals 0. This would be, using that color again, 2 cosine theta minus 2 sine cosine equals 2. Which of these looks easier to solve? This one by far is what you should be thinking. By far this one. Because it only has one trig function. Alright. Factor. 2 sine out. You would get 1 minus sine theta equals 0. You might be saying there's two solutions, but only one will work. So 2 sine theta equals 0. There are two trig values that give us 0. Let's check the first one. Theta equals 0 or theta equals pi. Let's just check 0 because we need to work for both. When theta equals 0, 2 times 0, 2 times cosine 0, cosine 0 is 1. So 2 cosine 1, sorry, 2 cosine 0 minus 2 sine 0 cosine 0. 2 times 1, sine 0 is 0. Check. No, you don't want to check pi. Pi would give us negative 2. Negative 2 times 0. Oh, sorry, 0. 0 works. 0 is nice, right? You can also do it just by inspection. But sometimes you might have to do this, so I wanted to show you it. How can I do it by inspection? When theta equals 0, sine of 0, 1 minus 0, 2. At that point, when I plugged in theta, I would get theta equals 0. Sorry, when I plug in theta equals 0, I would get to that point, which is the starting point I want. Now, I'm really worried a lot of you are hearing this now and like, oh, I wasted all that time. No. Just because if you plot this point in polar coordinates, one of its representations would be this, does not mean it would work out nicely. Do not get overexcited. For instance, one of the representations for this point is negative 2 comma pi. And that's not right. That's just not going to be right. Because pi over here doesn't work. We just showed that. Pi in here would get you where? Oh, it would get you to 0. I would be at 2. I would have 0.2 comma pi. So you can try it. You can just try it. Okay, let me just hope it's 0. Let me just hope it's pi. I may even recommend that if this looked really painful. Like, this doesn't look that painful to me. It's not impossible to solve it. Master that, and you will have an easy time. I'm going to shrink everything. We are almost done. We're really close to being done. So dy dx when theta equals 0. You should see your homework. It's not as bad as this. 2 cosine theta 1. 4 sine theta 4 0. 4 sine 0 0. Just 2 on top. On bottom, sine of 0 0. Sine of 0 0. Cosine of 0 squared. Cosine of 0 is 1. 1 squared is 1. So the slope is negative 1. So my slope is negative 1. My point is 2 comma 0. Y minus 0 equals negative 1, parentheses, x minus 2. That's my tangent line. Label. Nice. A lot of work. There's a lot of work there. A lot of work to make sure you're right. Again, if you get lucky and try theta equals 0, you would see you get that point. Okay, nice. Last problem. Second to last problem? Sorry, that was wrong. Okay. Find the points at which the graph of r equals 2 minus 2 cosine theta has horizontal tangents. The first thing I would think about doing is to graph. Okay, so let's graph it. What shape is this? You can look right here. Okay, so I see a number minus number cosine theta. Guess what? It's a limicon. It's a butt shape. Too far. 2 minus 2 cosine theta. Theta equals 0. Here we get the pole. Okay. I mean, I can write it out, but I'm gonna have to shrink it. R theta 0 0. Cosine of 0 1. 2 minus 2 0. Pi over 2. Let's check it out. Cosine pi over 2 0. 2 times 0 0. 2 minus 0 2. Pi. cosine of pi is -1. I'm up to 4. 3 pi over 2. You all know the story. You're back at 2. Okay. So, pull. Pi over 2 out. Pi over 2 rotation. Up 2. Pi rotation. Out 4. Go out 4. Rotate it. 3 pi over 2 rotation. 2 out. Go out pi over. Go out 2. Rotate 3 pi over 2. Over here. Butt shape. Heart shape. Limaçon shape. What do you get back? Okay. So we see a number of possible candidates for our horizontal and our vertical tangents. Now, by symmetry, these will probably be at the same points, but you need the points. You need the points. That means I need an X and a Y. I need an X and a Y. Okay. Sorry, it doesn't say vertical tangents. Oh, goodness gracious. I'm so happy. You don't even know. Okay, horizontal tangents. What's true? Slope is 0. dy dx is 0. So we have to find dy dx again. Find dy dx. It's our first step. It's our plan of attack. Okay, guys. It's okay. Find dx d theta. X equals our cosine theta. Let's highlight in blue this time, because it was blue last time. R equals 2 minus 2 cosine theta. Well, that's R, so X equals 2 minus 2 cosine theta. Now I'm going to blow through this derivative, both to impress you, and because I'm tired, and because you can watch the last slide to see how this is playing out. I'm not going to not write anything. I'm just going to do it quickly. Sorry, we're doing dx. I'll write it in orange, I guess. Orange. Aren't you glad I didn't say orange? Okay. Differentiate with respect to theta. Derivative of cosine. Negative sine. Keep the 2. Same thing. Same thing as this. But remember, we have to worry about the power rule here, and the chain rule, and the derivative of cosine. It's complicated. I'll even write it out for you. 2 cosine theta times the derivative of the inside. Sine theta. Negative sine theta. Ugly. Dx d theta is negative 2 sine theta plus 4 cos theta sine theta. Muy ugly. Okay, ready? Part 2, find dy dx. I'm just trying to give you guys practice at this. Oh, it shouldn't be that color because I just used that color. Sorry. Y equals r sine theta. R, right there, buddies. So y equals 2 minus 2 cosine theta times sine theta. Y equals 2 sine theta minus 2 sine theta cosine theta. Now, guys, we just did a derivative like this, where in the last problem, So make sure you use the product rule. Shall be very important here. Let's use pink. dy d theta 2 cosine theta minus first minus 2 sine theta times the derivative of the second, negative sine theta. Let's see if I can grab just this green stuff. Oh, that's fine. I can shrink it this way. You know what? I'm trying to find dy dx. You know it. Just rewind the video. Okay, plus the second times the derivative of negative 2 sine theta times negative 2 cosine theta. Because the derivative of sine is negative cosine. Sorry, because the derivative of sine is cosine and we have to keep the negative 2. My bad. Now, before you start crying your eyes out, trust me, I'm already crying on the inside. 2 cosine squared theta. Again, don't get excited. Sine squared, cosine squared, they have to be adding. These don't even have the same numbers in front. Should they? Yes, they should. My bad. Okay, again, either way, don't get excited. Okay, guys. Before you get mad, though, seriously. Don't worry. I see it. Before you get mad, here we go. Watch this. Notice. dy dx equals 0. We have to use dy d theta over dx d theta. This is notice. But if we have a fraction equals 0, it means the top equals 0. Yay. So we just have to set this equal to 0. We didn't need to find that. We didn't need to do it. I want to go through it again just so you're familiar with the process. No kidding. All right. That's a major yay. You should be ecstatic about that. I know I was when I wrote it. So, I want to set dy d theta equals 0. Okay, we have a bunch of stuff in terms of cosine and one thing in terms of sine. It's sine squared. I'm going to use the Pythagorean theorem, Pythagorean identity, I'm sorry. Use sine squared equals 1 minus cosine squared. We did this in class in AB just the other day. Make sure you're familiar with this. It's a hugely important idea to make simple things which are complex. Why is it grabbing both now, but it wouldn't grab both earlier? Isn't that dumb? Alright, anyway. We're going to use this idea to help us out right here. So stupid. I'm so triggered about that. You can't even tell. Well, you can tell, but you don't even know. Okay, so this whole equation is going to be rewritten. Because again, all I need to do is set this equal to 0 to find the places at which, the points at which. So, equals, this is not on color pink, huh? Sorry. 2 cosine theta plus 2, parentheses, deep breaths, happy thoughts. It's just trig. It's so much fun. Minus 2 cosine squared theta. Same thing. dy d theta. I know I'm writing on a tilt. It's because I'm tilted. Ha 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 ha. Not really. dy d theta. Let's try to get back onto solid ground. 2 cosine theta plus 2 minus 2. Distribute, please. Minus 2 cosine squared theta. One last push to simplify, guys. I'm going to put the squares out front. Negative 4 cosine squared theta plus 2 cosine theta plus 2. Boom. Ooh-yah. It's quadratic. You should notice that. I'm going to factor. You might be thinking, oh, Mr. Leven, you said one last thing to simplify. Yeah, kind of. But I also said that now it's going to get fun. We're moving away from simplifying and toward factoring, which is something we're good at from algebra. I want to factor a negative 2 so that the coefficient in front is positive. I think that's something that's often overlooked in algebra curricula. So be careful about that. Because it really helps your factoring get better, and you don't have to worry about the negative. You can just always factor out a negative. Keep factoring. Why? Because I'm going to try to set it equal to 0. 2x squared minus x minus 1. If you can't see how I'm factoring this. It's just that polynomial, but x's are cosines. So you don't want to really have this written on your paper. Or you might have it written on the side, like the ramblings of a lunatic. The idea is I want to use 2 cosine theta plus 1 times cosine theta minus 1. You can check that it works out, because this is 2x plus 1 times x minus 1. However you want to get it, do it. Okay, that's the connection. So dy d theta equals 0 when 2 cosine theta plus 1 equals 0 or cosine theta minus 1 equals 0. 2 branches, 2 colors, 2 houses both alike in dignity. Here we go. 2 cosine theta equals negative 1. Cosine theta equals negative 1/2. Okay. What values give me cosine theta of negative 1/2? Cosine theta of negative 1/2. We would have theta equals negative 1/2. So cosine is going to be negative over here. We would get, perhaps you're thinking of, you want some pi over 3 angles. You should be able to do that in your head. Pi over 3 angles. What do we got over here? We have 2 pi over 3 and 4 pi over 3. I'm trying to give you guys think time. If you need time to think about this, pause the video. I was listening to it the other night, and it just sounded like maybe I didn't know what I was doing, but I do. If there's any randos watching, I know what I'm doing. Cosine of theta equals 0. Oh my gosh, cosine of theta equals 1. I know what I'm doing. Cosine of theta equals 1 has only one solution between 0 and 2 pi. It's 0. Okay? So theta equals one of these 3 values, or all of these 3 values. Which one doesn't work? Okay, so we have to look at the graph. This doesn't work. Not good. It's this point. Because I did my table. When theta equals 0, I'm here. This is like a sharp curve. sharp turn. These other points, smooth as butter. Right up here and right up here. Okay? Now, I don't think I drew this very good. Oh, wow, very well. I'm just going to emphasize what it's supposed to look like. Clear those out. 2, oh my gosh, up. 2 minus 2 cos theta. Graph. Oh, yeah, see, it's flatter further out. I misdrew it. It's flatter over here. That's why. It looks kind of flat here. Just picture it over there. See? I am done with this. Well, let's leave it out for one more, just in case I accidentally use it. Okay, so we have these two values of theta. And now I'm going to shrink everything. Even the limison? Even the limison, because I'm really close to being done. I have my two values of theta. Alright, here I go. Theta equals 2 pi over 3. Would give me r equals cosine of pi. Guess what? At 2 pi over 3, we already figured it out. 2 cosine of theta equals -1. Now that's extra smart. No offense. Not no offense, but like, not to toot my own horn. But that's kind of what you want to be doing at this point, because God forbid you have to plug that back in and refigure out that we're getting something ugly. You should be able to reason by symmetry they're the same point also, because it's symmetric across the x-axis, so they both have to have the same value. So we have 3 comma 2 pi over 3 and 3 comma 4 pi over 3. I don't know why I circled just that one. Done. So those are the horizontal tan points. Right there and right there. Oh wow. Oh, it was so good for a second. Gasp. Alright, there we go. Alright, one more. You're almost done. Pause it. Go take a break if you need to. It's okay. I'll still be here. Recording the video. It's 7:30. Oh my gosh. Okay. Find the equations of the line's tangent to r equals 4 sine 3 theta. 4 sine 3 theta. Number, sine, number, theta. And is odd. Is this the one we graphed earlier? It is the one we graphed earlier. Oh, joyous day. We didn't graph the other one. Okay, cool. So, you don't have to take my word for it. I was getting all ready to say that. It looks like this. I think that's longer. It's a longer bow. It's more like that. Oh my gosh, not like that though. Like this. I'm gonna just try to draw again. Oh wow. It's late. That's what happens when it gets late, children. Teacher gets tired. Teacher gets so tired. Okay. That last bow is too short. Way too short. Ridiculous. That's going to be good enough for me. Find the equations of the line's tangent at the pole. Tangent at the pole. Guess what, guys? To be tangent at the pole, set r equals 0. That's all you need to do. It's going to be so nice as a cooldown. 0 equals 4 sine 3 theta. 3 theta would be one of the many values. Well, let's just 0 equals sine 3 theta. So what values of sine, what inside of sine would make 0? So 3 theta would have to equal, well, gee, the many things that would make sine equal 0. Many, 0, pi, 2 pi, dot, dot, dot. Every multiple of pi. So theta equals 0, pi over 3, 2 pi over 3, dot, dot, dot. Now you might be like, what? What? Are those lines? Yes. This is my final answer. Are they lines? Oh wait, you can't graph them because again, sorry, I was getting excited. That says R. These are all lines. These are each a line. What line is it? Theta equals 0. This line. Theta equals pi over 3. This line. Yes. No? No, it's back at 0. Every single time I hit here, I'm getting back to here. I think we're talking about this line. Yeah, no, these leaves were at... These leaves we talked about were at pi over 6. At pi over 3, we're back to the origin. Yes. So, don't think about drawing it on the picture. Let's just say that. Those are the equations of all the lines at the poles, right? These theta values were guidelines on there, everybody. I think it's like this. Maybe not that one. This one. This one. And then all over again. Okay? It's going to be beautiful. That's all you have to do for lines equations, lines of tangent lines at the pole. Set R equals 0. Okay? This was an incredibly long lecture for me. I spent all day talking about this, literally. From 5:30 in the morning until 7:30 at night. So if you finish watching this video and you are confused, that is totally understandable. Polar is a nightmare for a lot of students. It doesn't have to be, though. This is as bad as it gets. The formulas for area are not that bad. It's confusing. Don't worry, we'll spend a lot of time talking about it. If you are confused, please come in. I'm happy to talk to you about this in person. Maybe I'll do a session in person for this, but it takes a long time, as you can see. Please remember to do the problems for homework. I'm going to put an annotation at the top of the video saying, like, if you guys want to just pause the video and try out some problems and then come back, that's probably your idea, because I think this is one of the longest videos yet. Okay, guys. Remember to do the practice. If you're not doing the practice, you will not pass the test. Like and subscribe for me doing this over the course of 14 hours today. Okay, I said like and subscribe. Now I'm a true YouTuber. I appreciate your work, your focus, your dedication if you made it to the end of this video. We're almost done the course. This is 9-2, 3, 4, 5, 6, and we're out. Keep up the good work. I'll talk to you soon. Have a nice day. Goodbye.